Hi guys, my name is Bapi Hamed and welcome back with this video. So guys, in this video, we'll be discussing about data representation. So I think you already know what is data representation. That means inside generative AI, you will be working with textual data. So not only textual data, you will be also working with something called image kinds of data. Now, these are the actually raw file. If you see any kinds of text data, any kinds of image data, okay, so these are actually raw data. These are actually unstructured data. So I can't directly pass these kinds of data to my model because model is nothing but at the end it's a mathematical equation only, right? And mathematical equation can only support numerical data. So what we have to do, whatever text data, whatever image data we are using here, we have to convert them to the vector. That means we have to convert them to the number, okay, numerical representation. So this concept we call it as a data representation. You can also call it as a data vectorization. Okay, so here we'll be seeing couple of technique we can follow to perform these kinds of vectorization technique on top of our data. Even I will also show you some drawbacks with different technique, and which technique actually at the end you have to follow for the generative AI. If you're working in the generative AI, if you're working with the large language model, so which technique would be suitable for your task. Okay, so here everything I'll try to clarify, so please try to watch this video till the end. And if you have any kinds of doubt, you can also ask me in the comment section. So let's start guys with our data representation topic. So guys, in this video, I'll be discussing about like what is feature extraction from text. You can also consider as image. Then we'll be discussing about why we need it. Then third, I'm going to discuss why it is so difficult. Then we'll be discussing about what is the core idea and some techniques. So this should be my entire video agenda. So first of all, we'll be discussing about what is feature extraction from text. You can also consider as image, because I told you in generative AI you can use any kinds of data, whether it can be text, image, audio, okay, anything. See, first of all, we have to understand what is feature extraction. See, feature extraction is nothing but, let's say you are having a unstructured data. Let's say you are having a text data, or let's say image data. So from this data, you are extracting some features to represent that particular data. So I think those who are already familiar with computer vision, you already learned about convolutional neural network. So with the help of CNN, what we can perform a feature extraction. That means we just try to extract some of the features from an image. So what kinds of features? Let's say the edges, okay. Then you'll be also extracting some patterns. So these are the actually features. So with the help of these particular features, my model will be able to understand about the data, and it will be able to predict something, okay, on top of the test data. So this is the idea. So in generative AI also, what kinds of data actually we're using, we also need to perform something called feature extraction, because whether it can be text data, image data, any kinds of data, the first thing what you have to do, you have to extract the features from that particular data. Okay, this is the idea. And feature extraction means you are converting your textual data to numerical representation. That means to the vector representation. Okay, this is the idea. Then the second thing actually you can see why we need it. Because as I already told you, in generative AI, whatever model you are using, whatever large language model you are using, every model is a mathematical equation. And mathematical equation can't take actually your textual data or image data directly. So for this, definitely you have to convert to the number. Okay, numbers. You can also call it as a vector. Okay, vectors. So if you can convert to the numbers or vectors, then your model will be able to take this particular data as an input, and it will learn, okay, what kinds of actually pattern it is having. Based on that, it will try to generate something. This is the idea. Okay, now why it is so difficult? So whenever I'm talking about text data, okay, whenever I'm talking about text data, it would be a little bit difficult for you to extract the features from the data. Why? So let me show you some example. Let's say if I'm considering, let's say ML in machine learning, I think you remember inside machine learning, what kinds of data we used to use? I think you remember we used to use something called tabular data. Okay, tabular data. Tabular data, like we used to use something called CSV data, then Excel. Fine. So these are the actually tabular data. That means here you will have a table. So let's say this is your table. So it will have one fixed table. So in this table, you will have the fixed column size. Let's say you are having here 1, 2, 3, 4 column and sum of the rows. So 1, 2, 3, 4 columns, 1, 2, 3, 4, 5 rows. Okay. So here your table dimension is 5 cross 4. Okay. So this is the table dimension. That means it's a fixed size. It's a tabular data. Okay. It's a tabular data. So here you will have the column. Okay. Here you have the column. And here you will have the row. I hope you cleared. Now you will store the data. Fine. Now whenever you are taking any kinds of, let's say, machine learning model, let's say this is your machine learning model, your ML model. So what you will do, so what is the X feature size? X feature size is nothing but your input size. Okay, input size, that means the independence variable. Let's say you are doing house price prediction. So let's say this is number of room. Let's say this is the area of the house. Let's say this is number of bathroom, and this is the price of the house. So this is your Y variable. Okay, and these are your X variable. Okay, so X variable I'm having how many? 1, 2, 3. 3 X variable I'm having. Okay, that means you will give 3 input to the model and only 1 output you will get, which is nothing but Y hat. Okay, this is the idea. That means to the model you have to give X data 3 column and Y data 1 column, which is nothing but your price, and this is your target variable. Okay, and once you pass the data, you will get the output. That means here your column size is fixed. So here what you saw, your column size is fixed. That means your input size is fixed. Okay, to the model. Okay, there is no issue. That means we can easily use our tabular data. Okay, for in the machine learning, or you can also use in the deep learning. For this you have to use something called neural network. That means artificial neural network, right? Now let's consider image data. Let's say inside computer vision we use something called image data. Okay, image, videos. And whenever I'm talking about videos is nothing but it's a frame of image, right? It's a sequence of image. So you can convert videos to image, then you can analyze, again you can convert to videos. So let's consider image only here. So let me show you. See, image is nothing but it's a pixel. Okay, inside image actually we'll see different pixel values. So let me show you one example. So guys, here you can see here I kept one image, and this is a MNIST digit image. So here you can see 3 has been written. So if you just zoom this image, what you will see these kinds of pixel. Okay, and inside pixel you are having different numbers. You can see these are actually numbers. So this number range would be 0 to 255. Okay, 0 to 255, this is the range of the number. And one thing, wherever you can see the 0, okay, 0 number, you can see it's a white pixel. Okay, it's a white pixel. And whenever you see some number, okay, it's a black pixel. You can see whenever you can see much darker color, it's that means it is close to 255. And whenever you see some mild like darker color, that means it is close to 0. Okay, so this is the idea. Let's see your 3 looks like that. Let's say this is the 3 in this image, and here is the 3 representation in the number. That means if you zoom this image, you will see some numbers, that some value, pixel value would be there. Okay, so that's how actually your 3 looks like. So whatever image you are taking, you'll be getting this kinds of pixel value. Okay, at the end. Now whenever I'm talking about image data, so you can easily convert image to a table representation because it's a pixel value at the end. So what you can do, you can create a fixed table. You can create a fixed table. Let's say this image dimension is 28 cross 28. Okay, now just try to calculate the pixel value. Based on that, just try to create the table and add all the number here, add all the pixel. Now if you calculate all the pixels here, so if you just multiply 28 cross 28, you will get something called 784. Okay, I think that many of pixel. So this should be your input size. Okay, this should be your input size. Now what you can do, you can create a neural network. Okay, dot 784. Now just pass all the data one by one. Okay, pass all the data one by one, and so on. Okay, till 784. Okay, so that's how again you can create a easy neural network. And here input size is also fixed, which is nothing but this is the input size, because all the image will have the dimension, fixed dimension. Okay, I hope it is clear. That means there is no issue with the input size. Now the next data, let's talk about audio data. Okay, audio data. So audio is what? Audio is nothing but, so what is audio? Audio is nothing but it's a frequency. You can see it's a frequency. So whenever you will see some audio, you will get this kinds of frequency response, and the parameter of the audio would be dB. Okay, that means decibel. Okay, this is the frequency of the audio. Now you can easily convert this audio signal to a number representation, because here you can see, let's say this is your hertz. Okay, this is your hertz, frequency hertz, and this is your dB, that means decibel. Like, and now you can see this is the actually frequency. Now just try to see the graph, and based on that just try to collect the number. Let's say you have created one table. Let's say this is your table. So one column you just consider, let's say this is the frequency and this is the decibel. Okay, dB. Now just try to collect the data. Let's say here you can see 400 hertz and the decibel value was, let's say, minus 10 dB. Okay, that's how just collect all the data. Okay, collect all the data. Now again you will see we'll have one fixed table. Okay, we'll have one fixed table. Again you can take a deep learning model here, let's say artificial neural network, and you can feed the data. You can feed the data and you can get the prediction. Okay, again you don't have any issue with the input size. But whenever I'm talking about, let's say, text data, whenever I'm talking about text data, so here you will get the difficulty. How? So let me show you. So let's say this one sentence I'm having, my name is Bappy. So here just try to see how many tokens you are having. So we are having 1, 2, 3, 4. That means 4 tokens. Let's say somehow you converted this text to a number representation, that means vector representation. Let's say my you are considering as 0, name you are considering as 1, is considering as 2, and Bappy you are considering as 3. Now you will be creating a network. Let's say this is your neural network, 1, 2, 3, and 4. Then what you will do, you will feed the data. Let's say my will come here, name will come here, is will come here, and Bappy will come here. Okay. Now let's say you have taken some hidden neural network, and here you will get the y hat. Okay. Now let's say there is another sentence, how are you? Now see, here you will get the difficulties, because in the previous sentence, how many tokens I had? I had 4 tokens. Now if you count this sentence, you are having 1, 2, 3, only 3 tokens. Now let's say you have represented these tokens 4, 5, 6. Okay, let's say this is your vector representation. Now tell me, can I pass this particular data to the model right now? Because what is the model input size? 4. But here what is the input? You are having 3. So here you will get one dimensional issue. Okay, dimension issue you will get. Okay, so it will give you one error. So it is expecting 4-dimensional input, but you have given 3-dimensional input. Now just try to consider, whenever we write any kinds of text, it doesn't have any kinds of input length similarity. Okay, you can write anything. You can write, my name is Bappy, how are you? I'm okay. So it should be any kinds of length sentence. Okay, it can be any kinds of length sentence. And there actually we usually face the difficulty whenever we use these kinds of textual data, because it doesn't have any kinds of input size, because it's a completely unstructured data. And representing this text to numbers is very much difficult, because I can't assign 0, 1, 2, 3 like that. Because if you're assigning 0, 1, 2, 3 like that, your model won't be able to understand. It's not a meaningful number. But previously, the data I showed you, we can easily convert them to the numerical representation, because tabular data is already a numerical representation data, right? Then image is already a numbers, because at the end you are getting a pixel here. Then audio is already a number. You are getting a number here. But what about text? Text is a string. But how we can convert a string to a number representation so that it will have the same meaning of my sentence? Let's say here I have written, my name is Bappy. So after my name is coming, after name is coming, after is Bappy is coming. So with the help of number, how I can, let's say, contain that particular relationship? Is it possible? Yeah, it is possible, but it would be a little bit difficult for you initially, because you don't know like what kinds of, let's say, vectorization you can perform here to represent this particular sentence to a, let's say, meaningful representation. That is what I'm trying to say, right? So now you can ask me, sir, we can apply actually 2 techniques we have learned previously. I will tell you what kinds of technique we can apply. You told me, let's say the first technique we can apply something called one-hot encoding. One-hot encoding. So this encoding technique you have learned in your machine learning, right? That's whenever you have any kinds of categorical data used to perform this one-hot encoding, right? Then the second technique, you can also perform something called bag of word. Bag of word. You can also call it as a bow. Okay, bag of word. So now let's try to discuss these 2 techniques how it can be applied and what are some drawbacks, okay, if I were applying these kinds of technique. Okay, so first of all, let me discuss one-hot encoding. So what I'll do, I'll just create a table here. So let me create a table. So here I will take 2 columns and 4 rows. As of now, I'm only taking 4 example just to show you, okay, how things will be working. But in actual way, we'll have more than actually 4 rows. Okay, that means you might have thousands rows, let's say lakhs of rows. Okay, it doesn't matter. Let's say this is your data 1. So here you are having a sentence. Let's say people watch. Let's say I'll give my YouTube channel name DS with Bappy. So if you don't know, guys, this is my YouTube channel name. If you're interested, you can also visit. Then let's say data 2 we are having DS with Bappy much DS with Bappy. I'm writing any kinds of sentence, guys, as of now, whatever things I'm thinking in my mind. Now it's a data 3 you are having people write comments, and data 4 I'll be writing D4 DS with Bappy write comments. Okay, let's say these kinds of data we are having initially. Fine. So that means how many rows we are having? We are having row 1, row 2, then row 3 and row 4. That means only 4 row we are having as of now. Okay, 4 example we are having, 4 data points we are having, right? Now if I want to perform one-hot encoding, so first thing what I have to do, I have to take the entire corpus. Okay, and I already told you what is corpus. I think in my previous session, the text preprocessing session, at the last I was discussing about some like key important things you have to remember. Okay, so whenever I'm talking about corpus, that means your entire data. So just try to collect your entire data. Let's say people, then you have the watch, then you have the DS with Bappy, then you are having then again you are having DS with Bappy, DS with Bappy, then again watch, then again DS with Bappy, then you are having people, then write, then comments, then again DS with Bappy, write, comments. Okay, so this is your entire corpus. Okay, corpus. Okay, corpus of your data. Now from here you have to figure out how many unique word you are having. So we are having people, we are having watch, DS with Bappy, then write and comments. So these are the unique words. That means 1, 2, 3, 4 and 5. That means n is equal to 5. Okay, 5 unique word we are having. Now what we have to do, we have to create a table. Let's say I'll create a table with these 5 unique words. So the first word will come people. The second one will come watch. Then the third one will come, let's say DS with Bappy. Then write. Then comments. Okay, comments. Okay, so that's how your one-hot encoding will try to represent the data. Okay, let's say whenever you are using any let's say library in Python, so how this library works exactly to perform the one-hot encoding, that is what I'm explaining here. Fine. Now see how it will try to convert your text data to numerical representation. So first of all, it will take the row 1, that means D1, let's say people. Now just try to find people here. So you can see people is there. That means this should be 1 and everything would be 0. Okay, then watch. Now just try to find out the watch. So here is the watch, so it should be 1 and everything would be 0 again. Okay, then DS with Bappy, so it should be 1 and everything would be 0. Okay, so here the number actually we got, this is for the D1, that means data 1, row 1. So here I can write like that, let's say I'll just simply write d1. Okay, d1 is equal to, so here I got one two-dimensional vector. So here 1 0 0 0 0. Okay, then comma 0 1 0 0 0, then comma I got 0 0 1 0 0. Okay, so this is my d1, that means sentence 1. Okay, this is for the sentence 1. Okay, I hope you clear. Now again you will take the sentence 2, that means d2. Okay, d2. Now you will just try to find the numerical representation. Now let's find the d2 as well. So let's say ds with buppy. So again, let's say this one would be 1 and everything would be 0. Okay, so this is for actually d1, and now we are doing for d2. Now again it will see the watch. So watch is here, it would be 1 and everything would be 0 again. Now the next thing would be ds with buppy again. So let's say this is a ds with buppy and everything would be 0 again. Okay, so this is what actually your d2. So again I can represent like that. Let's say d2 is equal to 0 0 1 0 0, comma 0 1 0 0 0. Okay, then comma I'll take 0 0 1 0 0. Okay, so this is my d2. So that's how you have to complete for all the sentence. That's how you have to complete for all the sentence, and at the end you will get all the vector representation. Okay, you will get all the vector representation. I hope it is clear. Okay, how one-hot encoding can be applied. Now let's say you have completed for all the sentence and you got your vector. Now what you will do, you will just try to create a neural network. Now just see the input size. The input size for the model, you can see input size would be 1 2 3 4 5, because we are having 5 unique word only. So everywhere you can see 5-dimensional vector 1 2 3 4 5. That means you will be taking a neural network like that 1 2 3 4 and 5. Okay, inside that you will take some hidden layer and you will get your y hat here. Okay, so that means you will pass the data. Okay, you will pass the data in this particular layer. That means you will take this particular vector. So first of all you will do for the d1, you will take this particular vector, you will pass it here. Okay, then the second one you will pass it here, then the third one you will pass it here. Okay, that's how you will be passing for all the sentence. Okay, you will be passing for all the sentence. But let's say in case in your corpus, okay, in your corpus the number of unique word is 1000. Number of unique word is 1000. In that case, what should be the input size of the model? Definitely it will also become 1000s. That means you have to take 1-dimensional, sorry, 1000s neuron. Okay, at the very first. That means again complexity is increasing. Let's say in your entire corpus you are having 2000. Okay, 2000 unique word. So you have to take 2000 actually neurons. So if you're using one-hot encoding, that means the number of unique word you are having in that particular corpus, based on that your input layer would be decided. Okay, it's not a recommended, because if your input, if your let's say unique word is increasing, your neurons is also increasing, and whenever you are increasing the neurons, your calculation would be increased also, because at the end you are doing neuron calculation, you are doing the computation here, so computational cost will also increase, right? So that's why it's not a recommended way. Again, there is another issue. Let's say I'm having a sentence and which have actually the word which is not present in my corpus. Let's say I can write my name is Puppy. Let's say this sentence actually I'm having. Okay, now just try to see, these are the word is having in my entire corpus. No, these are the word is not present inside my entire corpus. Okay, that means what will happen, it would be out of vocabulary issue. That means the vocabulary you are having right now, it is not present inside your corpus, so your model won't be able to understand these are the word, because you haven't used this data during training. So whenever you are giving during testing, definitely it won't be able to understand what kinds of sentence you are giving. So again, it is called actually out of vocabulary issue, OOV. Okay, out of vocabulary issue. So if you are using one-hot encoding, so you will get this kinds of issue. Okay, out of vocabulary issue. And another issue I think you saw here, you are having lots of zeros. You are having lots of zeros, and zero is what? It's a sparsity problem. That means it's a sparse matrix you are having. Okay, and whenever you are doing the computation, and whenever you are using zero, okay, to perform any kinds of operation with number, so there is no meaning, right? That's why zero is an unnecessary number here. Zero is unnecessary number here. So you are unnecessarily increasing the computation here, because with, because you can see zeros is increasing the dimension in this particular case. So let me just write some of the drawbacks of the one-hot encoding. So here I'll just write the drawbacks. So the first drawbacks, you can see the sparsity. That means here you are having lots of zeros. Then the second, you can see the no fixed sized, because anytime your sentence might be anything. Okay, let's say here I have taken people watch DS with Bappi. I can take also my name is Bappi Ahmed and I'm a data scientist. Now just count of the sentence length. You will see that it would be bigger. Okay, so you can write no fixed size. Then the third, you saw OOV, that means out of vocabulary issue. And the fourth important things, it is not capturing semantic meaning. Semantic meaning means after people watch is coming, after watch DS with Bappi is coming, before DS with Bappi watch is coming, before watch people is coming. These kinds of semantic information, semantic relationship, this is not capturing because it's just a number. And whenever this word is present, it is giving 1, otherwise everything it is giving as 0. That means this particular number is not capturing the semantic information of your sentence. But whenever we are using text data, so definitely it will have the semantic relationship. That means it will follow one grammar. What kinds of grammar? Let's say whenever I'm writing any kinds of sentence, let's say my name is Bappi. So my is a subject. So my is a subject, name is noun. Okay, is verb, Bappi is also a noun. That's how it is following one grammatical rule. Okay, that means after my name will come, after name is will come, after is Bappi will come. Okay, so it is following one relationship. It is following one relationship like that, right? So this kinds of relationship, it won't be able to capture if you're using one-hot encoding. Okay, so that's why we can't use this particular method. Okay, we can't use this particular method whenever we want to convert our data to numerical representation, that means vector representation. Okay, inside generative AI. So this technique you don't have to follow because it's like very basic technique. If you're doing any machine learning project, if you have some level of categorical data in a column, you can use this one-hot encoding there. But whenever you are working with completely textual data inside generative AI, I won't suggest, don't use this particular method because I already showed you some of the drawbacks you will get here. So now the second technique we'll be discussing about bag of word. Okay, bag of word. Now let's try to see the bag of word example, like how it will work. So for this, I'm going to copy the same table. So again, you can consider the same things, corpus. So I'm using the same table. That means it will have the same corpus. Again, the number of, let's say, unique word would be 5. And you have to create a 5 unique word table. So let me again copy. Now, how this bag of word will work? See, this bag of word will work based on the count. Okay, based on the count of the word present in your entire corpus. So let's say, first of all, it will see people. So now just try to tell me how many times people you can see in this particular sentence. I can see only one time. So people is coming only one time. Okay. Now the next word, watch. So how many time watch is occurring in this particular sentence? Only one. Then DS with Bappi, one time. And write is there? No. So write is not there, it would be 0. And comment is not also there, it would be 0. Okay. Then the next sentence you can see DS with Bappi, only one. DS with Bappi now occurring 2 times. So it would be 2. Then watch is occurring only one time, 1. And people is not there. Write is not there. Comment is not also there, right? Now the third sentence, people is coming one time. Write is coming one time. Okay. Comment is coming one time. And watch is not there. DS with Bappi is not there. Now the last sentence, DS with Bappi only one time. Write is only one time. Comment is only one time. DS with watch is not there. People is not there. Okay. So this is how actually you'll be generating the vector. Okay, this is how actually you'll be generating the vector. Now just try to match with your previous vector. What you have observed, you see the bag of word technique you have applied, it is having very less zeros than your one-hot encoding. Okay, that means it is slight better than your one-hot encoding. Okay, because it is working based on the counting. Okay, based on the counting. Okay, counting of the word present in the sentence. Okay, this is the idea. Now research already proven that if you want to do something called classification kinds of task, let's say sentiment analysis, okay, sentiment analysis. Then let's say we are performing positive negative reviews. Okay, these kinds of tasks you can use this bag of word technique to perform the text vectorization, because this is suitable for this particular task. Because if you see any kinds of sentiment analysis problem, let's say here I'm having some sentiments, this movie is wow, or you can also write this movie is amazing, amazing performance. Okay, performance. Let's say these kinds of reviews you are having. Now if I want to find the positive, okay, positive or it's a negative, I can see the, let's say, word. So movie amazing, amazing performance. Okay, you can see amazing, this particular positive was is occurring like multiple time. That time I can consider it's a positive review. Okay, it's a positive review. So that is why it's a frequency based actually approach. So it will always try to see the frequency count in a sentence, and based on that it will decide whether it's a let's say positive sentiment or whether it's a negative sentiments. Okay, so that is why it is recommended if you're performing any classification kinds of task inside a text, you can use this particular approach. Okay, but again, one drawbacks you will see, it is not capturing the semantic information, like after DS with Bappy, what is coming, after what DS with Bappy is coming, or let's say people, what is coming, after what DS with Bappy is coming. So this kinds of semantic information it is not able to capture. So again, it's a drawback. Okay, and some of the zeros still you can see. Okay, because again it will increase that your computational cost, because zero doesn't have any kinds of meaning if you are doing any kinds of operation, right? This is the idea. Fine. So apart from that, we are having some more technique we can follow, like we are having something called TF-IDF. So we are having TF-IDF. Then we are also having another technique called word to vec. So this one use one statistical, let's say, equation to perform let's say vectorization, and this one is the deep learning based actually vectorization technique. Okay, and from this technique actually lots of idea came how we can use the transformer model to perform the feature extraction, because whenever I'll teach you this word to vec technique, I'll show you the feature extraction technique. So how it will extract the features from a sentence, let's say from a text. Okay, so from here actually idea came, then people have actually launched transformer based actually encoding technique. That means with the help of transformer model you can perform the text representation. That means you can convert your text to vector representation, and whatever large language model you are using, okay, LLM, you'll be using this transformer based approach only to convert your data to the numerical representation. So whenever we'll do the practical, that time definitely I will show you. Okay, we'll be downloading the model from the Hugging Face. Hugging Face is also having lots of tokenizer. That means this kinds of encoding model. Okay, with the help of that we can easily convert our data to the numerical representation. Fine. So as of now, let me show you all the practical. That means that's bag of word, then TF-IDF, then what to vec. Okay, how we can use it and all. But before discussing TF-IDF and what to vec, I just wanted to show you this bag of word practical. So for this, what I will do, I will open up my Colab notebook, and there I'll show you this particular practical. So guys, here you can see I already prepared one Colab notebook for you. So one-hot encoding I'm not going to show you, because you already know how to perform one-hot encoding. So with the help of pandas library also we can perform one-hot encoding. Even we also have one, let's say, class inside sklearn library, okay, to perform the one-hot encoding. So I'm expecting if you already work with machine learning, you know how to perform one-hot encoding. And again, we are not going to use one-hot encoding technique in our analysis, but bag of word will be using sometimes, because I told you now if you're doing any kinds of sentiment analysis and all, that time you can perform, because it's easy to implement. Okay, at the end. Now see, bag of word, for this I need two library, NumPy and pandas. So let me import them. So with the help of pandas, actually I'll be creating a data set first of all. So the same data set example I have taken, the data set I showed in my whiteboard. Okay, so you can see people watch DS with Bappy, DS with watch DS with Bappy. Okay, this kinds of example I have taken. Now let me prepare the data frame. Okay, so this is my data frame, and here I also have taken another, let's say, column called output. Let's say whether it's a positive, whether it's a negative. So that's how I've just given a number. Okay, it's just an assumption number as of now. Don't try to think it's an actual number. Fine. 1 means it's a positive, 0 means it's a negative. Okay, but whenever you will be using actual data, there will have the positive, negative reviews. Okay, based on the text you are having. I hope it is clear. Now, if you want to perform bag of word technique, you have to use one library called sklearn. From sklearn, you have to use something called count vectorizer. Okay, so count vectorizer is nothing but it's a bag of word technique. So I know that many of you already use this count vectorizer in your machine learning, but you don't know this is a bag of word. Okay, so now just try to remember it's a bag of word technique only, right? Now we have created the counter vectorizer object. Now here I just need to fit my data, and I want to fit my data on top of my text. That means textual data. Now here I'm fitting the data. Now it will return me all the vocabulary. Now see, what will happen here? It will just assign some of the index number. Okay, it will just assign some of the index number with all the words. Now whoever having actually 0, that means this is the first index. That means this word would be considered at the very first. Then this one, that means number 1, then 2, 3, and so on, right? Now how it is generating this particular array? So let me just try to discuss. Now just try to see which word is coming at the very first based on the index comments. Now just try to see comment is there in the first sentence. No, comment is not there. That's why it is coming as 0. Got it? Now the second sentence you can see. Now the second word you can see DS with Bappy. Now tell me DS with Bappy is there? Yes. How many times? Only one time. That's why it's coming as 1. Okay. Then the next one, people. People is there? Yes. How many times? Only one time. Okay. Then the next word, watch. Watch is there? Yes, is there. How many times? Only one time. Then the next one, I think last one, right. Right is there? No, right is not there. That's why it is coming 0. Okay. Now let's consider the second sentence. Okay. Now again, you have to consider based on the index. Again, comments is there. No, comment is not there. So that's why it's 0. Now next thing, DS with Bappy, yes, it is there. How many times? 2 times. That's why it's coming as 2. Okay. Then you can see the next one, people. People is not there. That's why it's coming as 0. Okay, it's coming as 0, 0. Then after people, actually, we are having watch. Watch is there. Yes, there. How many times? Only one time. Okay. Then after that, we are having something called this one. Right. Right is there. No, right is not there. That's why it's coming as 0. That's how you have to consider for all the sentence. I hope it is clear how it is generating this particular number. Okay. And this is your vector. Okay, this vector actually you can pass to the model. Okay, this vector you can pass to the model. So if you're only printing this bow object, see what you will get one object here. Okay, you will get one sparse matrix object. And if you want to get the number, that means the complete array, you have to use this particular method called toArray. That's why every time I'm doing this one. Okay, just to show you all the number. That is the idea. Fine. Now if I want to perform on top of my new data, let's say this is one sentence I've given, Bappy watch this with Bappy. So I have to use this particular transform. Okay, transform function that time, cv.transform, pass your data and convert it to array again. You will see your data representation. Fine. Now what you can do, you can store your X and Y data. Let's say X is nothing but my entire bow and Y is nothing but my output. So this is my output. Okay, positive or negative. Now you can pass this data to the model. Okay, this is the idea. Got it? Now there is another things inside bag of word called n-grams. Okay, what is n-grams? N-grams is nothing but here you see n-grams is nothing but here you do the same thing, only you give one n-grams parameter. So let's say if n-gram parameter is 2, so what will happen? Let's say n-gram parameter is equal to 2. That means it will consider 2 word as a 1 token. Okay, 2 word as a 1 token. See, previously I took individual word, right? Now it will consider 2 word as 1 token. That means here it will come people watch. Okay, inside this box people watch will come. Then watch DS with Bappy will come. Okay, so that's how you have to take pair of word. Okay, and you have to perform the same thing. So this is called actually n-grams. Now let's say n is equal to 3. That time 3 pair will come. That means 3 word you have to consider. Okay, but I saw that people are using only 2 parameter because sometimes it is required. So let me show you one example why it is required. So let's say here I'm having a review. Movie is very good, and here I can write it, this movie is not very good. Now this one is the positive sentiment, you know, this one is the negative sentiment, you know. Okay, but how about your model? Okay, how it will identify? Because I told you based on the frequency count it can decide. Let's say you are having some word, let's say very good movie. Okay, that means it's a positive one. And if it is coming to the second sentence, let's say this is the first sentence, the second sentence, again it can consider movie very good, and it will ignore this one because it's a stop word. I think I taught you the stop word concept, right? Not would be considered as stop word. So again your model will try to consider it's a positive. Okay, it's a positive review, but although it's a negative review. But how I can capture this negative information? So if I am doing this n grams, that means if n is equal to, let's say n gram parameter is equal to 2, it will consider 2 word as a pair. Okay, 2 word as a pair. So the first word, then second word, then this 2 word, and this 2 word. Okay, so it's a positive one. You can see now, you can see it's a positive one. So this movie very good. Okay, now again, if I just make this sentence, let's say this word, this word, this word, this word, and this word. Now you can see easily it is capturing is not. Okay, is not. Now see, it is easily capturing this is not. That means not word as well. Okay, now easily your model can identify it's a negative. Okay, it's a negative sentiments. Okay, so that's why sometimes we have to perform this particular n grams operation. Okay, because if you are giving n gram parameter is equal to 2, that time it will consider 2 tokens. Okay, in one just let's say representation, and it can capture some of the hidden information. Okay, this is the idea. Now let's see the practical. So here you can see the same example only. You have to use the counter vectorizer. I'll convert to the text. Now see, whenever I used counter vectorizer, here I have given a parameter n grams range is equal to 2, that means it will consider 2 words. Okay, now you can see people watch DS with Buppy, DS with Buppy watch. Okay, now it is considering 2 tokens. Okay, in just one representation. That's the idea. If you give 3, so if you give 3 here, it will consider as a 3 word. Okay, 3 word as a count. Okay, that's how you can consider. Fine. And if you're using 3 word, that means it would be considered as a trigram. Okay, trigram. And this if you're using 2 words, if you're using 2, it would be considered as a bigrams. Okay, this is the idea. Now there is another technique I already showed you, TF-IDF, that means term frequency inverse document frequency. So this will work based on one equation, based on one, let's say, statistical equation. So simply in Google you can search for this equation TF-IDF. So you'll see this particular formula. So yes, this is the formula, guys, it use, okay, to perform this text representation technique. Okay, so it will work based on the, let's say, weight. Let's say if anyone word is having, let's say, frequent count, okay, in a sentence, it will give more weight. Okay, it will give more weight. Now if I show you the representation, so you have to use this sklearn to initialize TF-IDF vectorizer. Now inside that you can pass your data. Let's say text data I'm passing, I can name converting to the array representation. Now see, you are getting the entire array. Okay, now see, none of the number is 0, complete 0. You will still get some number. Okay, it would be a floating number. So this technique helps us to reduce that sparse matrix dimensionality issue, because if you are using 0, okay, 0 in your, let's say, vector, you are doing unnecessary computation. That's why it will assign the weights, and weight is nothing but it's a floating number. Okay, and everywhere you will see the floating number. So this particular issue will be resolved, because still after performing bag of word you are generating some zeros. But if you're using TF-IDF, you are not generating any kinds of zeros. Okay, so this is the main benefit here, and this is better than your let's say this one, bag of word. Okay, sometimes you can also use this TF-IDF technique. Again, I won't be recommended to use this one, because we have some better option to do. Next thing I will be teaching you that what to vec technique. That means we'll be using deep learning model for the feature extraction. Okay, and this will contain the semantic information, because again, if you see, this TF-IDF is not able to actually contain the semantic information. That means after, let's say, people watch is coming, after watch DS with Buppy is coming, this kinds of semantic information is not able to capture. Okay, so again, I won't be recommended to use this TF-IDF technique here as well. Fine. And here is the some TF-IDF value. Okay, if you are understanding this formula, you will get it. Okay, what kinds of things it is generating. But initially I won't be suggesting you to deep dive in this equation, because again it's not a recommended. We won't be using it. Okay, we'll be understanding whatever actually we need, okay, for our large language model. That's the idea. So yes, these are some actually practical I showed you for the text representation technique and word embedding technique. Now the next thing we'll be discussing about this one, word to vec technique. Okay, now let's try to see how word to vec technique works. Okay, so guys, now we'll be discussing about word to vec. So this is the deep learning approach actually. So how word to vec works and how it will extract the features from the data itself, I'll try to clarify. See, word to vec actually use two kinds of architecture. So if you want to see, just write word to vec architecture. So you will see it has actually two kinds of architecture called CBOW. So here you can see, guys, it uses two kinds of architecture, CBOW and skipgram. So it's a neural network only, right? So let me show you the core mechanism of What2Vec, like how it extract the features. Let's say you are having documents. Let's say you are having an entire corpus, and in the corpus, let's say you are having some unique word. So let me create a table. So I can create a table. Just a minute. So here I'll be adding all the features, and this side I'll be adding all the unique word. Let's say you are having the word of king. Let's say queen. Let's say man. Let's say woman. And let's say monkey. So as of now, just try to consider these are the unique word you are having in that particular entire corpus. Now, how your What2Vec will try to extract the features. So see, it's a neural network, and neural network works based on the back propagation, because every time it will adjust the weight, based on that it will learn. And if you see the neural networks, you can't see like what kinds of feature it is extracting, because it's a completely hidden thing. If you see for the, let's say, CNN, if you see the for the NN, so these feature extraction things is a completely hidden. You don't know what kinds of feature it will extract. But as of now, let's consider it has, let's say, generated some of the features. Let's say the first features it has generated based on this word gender, because gender features can match with all the words you can see, because all the, let's say, word I'm having, let's say all the entity I'm having, it has the gender, yes or no, right? Then it has also generated another features, let's say wealth. Now you can see wealth is also matching with all the words. Now you can also consider power, then weight, then speak. See, as of now, I'm just assuming these are the features my model has generated, because here we're using deep learning model. I think I showed you. Now see, that's how actually it will identify the features. That means the vector representation. First of all, it will see king has gender or not. Yes, king has gender, and it's a male king. Let's say male king. Queen has gender. Yes, let's say 0. 0 means female. Man has gender. Yes, 1. Woman. Yes, that means 0, because man I'm considering as 1, and woman I'm considering as 0, right? Monkey has also gender. Let's say 1. Now wealth, king has wealth. Yes, king has wealth. Let's say I can assign as 1, because king is having lots of wealth. Queen is also having wealth, let's say, because queen is a part of king, right? Man is also having wealth, but less than king and queen, so I can give, let's say, 0.5, okay? Or I can give, let's say, 0.2, fine, because again they are king and queen, right? Woman has also wealth, let's say 0.2, less than man. Monkey doesn't have any wealth, I will give 0. Now power, yes, definitely king has the power. Queen also has the power, okay? But I can just decrease a little bit. Let's say less than king, okay, I can give 0.7. Man has also power, let's say 0.3. Woman has also power, let's say 0.2. Monkey, no, monkey doesn't have any power. Now weight, yes, king has weight, let's say I will give 0.8. Let's say this king is a little bit obese. Queen, yes, she has also weight, I can give, let's say, 0.5. Very slim queen. Man, let's say 0.7. Woman, let's say 0.5. Monkey, let's say 0.3. Fine. King can speak. Yes, king can speak. Queen can also speak. Man can also speak. Woman can also speak. Monkey, let's say, can't speak. Okay. Now see, beautifully, I have generated some of the vector. Okay, beautifully, I have generated some of the vector. And I haven't generated, it has generated by your What2Vec algorithm. Okay, What2Vec model. That means this architecture, the deep learning architecture you saw. CBOW. Okay, CBOW and skipgram. Okay, so these are the architecture. Let's say it has generated these features. Now if I tell you, just try to give me the king vector. So what it will give me? It will give me, let's say, king is equal to, let's say this is the king vector. So I can write here 1, then 1, then 1, then let's say 0.8, let's say 1. This is my king vector. You can also give me the queen vector. So here is the queen vector 0, 1, 0.7. Let me just write 0, 1, 0.7, then 0.5 and 1. Okay, this is the queen vector. You can also give me the man vector. Yes, the man vector 1, 0.3, 0.3, 0.7. 1, 0.3, 0.3, 0.7 and 1. Okay, then woman 0, 0.2, 0.2, 0.5, 0, 0.2, 0.2, 0.5 and 1. Then let's say this is the monkey vector 1, 0, 0, 0.2, monkey 1, sorry, should be 1, then 0, 0, 0 0.3, 0, 0, 0 0.3, sorry, 0 0.3, and I think 0. Okay, see all the vector I got. Now if you plot them in a dimensional space, let's say this is my dimension. As of now, I'm just drawing two-dimensional dimension, okay, because 3D, 4D I can draw here. That's why I just consider two-dimensional space. Now here you can, let's say this is your x coordinate, this is your y coordinate. Now let's say first of all I want to, let's say, represent king here. So let's say king is here. Let's say this is the king. This is the king vector. Okay, this is the king vector. I can write this is the king. Now if you just plot the queen also, you will see that queen will come close to king. Okay, queen will come close to king. Why? Because if you see the vector, okay, if you see the vector, they are very closely related vector. You can see, let's say if you calculate the queen distance with respect to all the vector, you will see that queen will have very less distance with the king because both are similar. Okay, both are similar. Okay, because you can see queen is the part of king, so all the features are already matching with the king. That's why it is coming to close. So that means it's a cluster. Okay, it's a cluster of king and queen, so they are falling in the same cluster. Now similar wise, if you plot the man and woman vector, you will see that they will come nearly. Let's say this is your man. Okay, man vector, and let's say this is the woman vector. Because if you see carefully, man and women vector, they are closely related. Okay, they are almost similar, so that's why they are coming in the same cluster. So again, it's a cluster, okay, for man and woman. And if you see the monkey, okay, monkey is a completely different entity. You can see the vector is also different. So let's say monkey will come here. So I can take a new pen. Let's say this is the monkey. Monkey, okay, and monkey, it is present in the different cluster. Okay, so that's how it is capturing the semantic information, okay, between multiple words. Now let's say there is another sentence you are writing. Let's say I am a princess. Okay, princess. Now tell me where this princess will come, in which vector, in which space, okay, in which cluster. It will come definitely inside this particular cluster, because if you just extract the features from the princess, you will see that it would be close to king and queen. Okay, so that's how this word to vec can actually understand the semantic information of a word. Okay, so that's why it is so that's why word to vec is the much better than your previous whatever technique you have learned so far. Okay, and from here actually your actual concept starts, like whatever things you will be learning in future. Let's say transformer based encoding, like how transformer model extract the features. That's how it extract the features. Okay, because at then it's a deep learning model, and by the backpropagation itself it will generate these are the features. But as a human you won't be able to see the features, but here we are assuming, let's say these are the features your model may create, and based on that, that's how it will generate the vectors embedding. Okay, and when it comes to semantic information, that's how it will let's say capture the semantic information, because it will plot all the vector in a dimensional space, and then it will try to find the relationship whether king and queen are same or not, man and woman are same or not, monkey is a different or not. Okay, I hope it is clear now. So let me show you one image actually, experiment of what to vec. You can see this is one experiment for the what to vec. So here you can see we are having three kinds of word: king, man, and woman. And whenever what to vec is applying on top of it, it is generating some features. You can see. So these color represent the features. Let's say these are the features it has generated. Let's say this is wealth, this is power, this is speed, this is, and let's say this is the weight. I can see king color is different than your man and woman. Now see, man and woman color, they're closely related. You can see all the color is matching. Okay, all the colors are matching. That's how it is making a separate cluster of man and woman, and king is a different entity here. Okay, I hope it is clear now. So now let's see the practical of what to vec, how we can use what to vec in a Python code. So for this I'm going to use one dataset. So let me show you the dataset here. So the dataset name is Games of Thorns book dataset. Okay, dataset in Kaggle. I think you know what is Games of Thorn. Okay, it's a series actually. So if you don't know, you can simply search on image. See, this is one actually series. Okay, this is a movie series actually, Games of Thorns. and it is having different characters. So if you have already watched this particular, let's say, series, you will know, okay, about this particular character and all. So based on this particular series, one book has been published, and this dataset is available in the Kaggle also, this book dataset. Now this book contains all the dialogue, okay, present in that particular series. Okay, see all the dialogue. It is having different txt file, you can see, based on the, let's say, season. Okay, it is having different dialogue from all the characters. So what I'll do, I'll just try to download one txt file, and I'll just try to apply what to Vec on top of it, and I'll try to see what are the character are closely related. That means I'll see these kinds of, let's say, representation. That means whether some character are in the same cluster or not. Because if you see this series, some of the character would be closely related. Okay, let's say character 1, let's say character 2, they're similar kinds of character. So these two vector will come closely. Okay, that's how we want to see the relationship, okay, between the data. So I already downloaded one txt file. You can also download. Just try to search for Games of Thrones books in Kaggle. You will see this particular data. Just try to download one txt file. So let me show you the notebook. So guys, this is the notebook, and here we'll be showing you the what to Vec. Now let me connect, and this dataset is already available in this link I have already given. Now let me download and let me upload in my Google Colab. So here I can upload this data. So I'll create a folder here called data, and inside that I can upload this txt file. Now first of all, let's import some library, NumPy, Pandas, and GenSim I'm importing because what to Vec is there inside GenSim library. Okay, if you want to use what to Vec, you have to use this particular library called GenSim. Inside that you have the what to Vec architecture. Now let me import them. Now if you're using Google Colab, first of all you have to update the GenSim, because otherwise you will get some of the issue. So let me update. Okay, update is done. Now I'm importing like sentence tokenizer from the NLTK, and I'm also importing simple preprocess from the GenSim library, because before passing my data to my, let's say, what to Vec model, first of all I have to apply some processing. Okay, processing means it will do some cleaning operation and all. Then you can pass the data. So let me import them. Now this code snippet will load your data from the data folder, you can see. Okay, so here I'm having test.txt, so it will load the data, and it will extract all the, let's say, word, that means all the sentence one by one, and it will perform the tokenization. Okay, it will perform the tokenization. That means every word will have the tokenizer. Okay, now if I show you this story, that means story list. Now see, you got your all the sentence. Okay, see, this is the entire sentence, and inside a sentence you have done the word level tokenization. Okay, this is the idea. Now if you check the length of the entire story, you have more than 8,000 actually, let's say example here. So here you are having more than 8,000 sentence. That means 8,000 dialogue. Okay, now you can see the entire story. Now if you want to see the story 1, that means the first let's say dialogue, the first sentence, this is the first sentence. Okay, you can see, and again we have done the word level tokenization. Okay, individual token. Now we have to initialize the GenSim model. So that's how we can initialize the GenSim model. So let me initialize. Then if you want to let's say convert to the vector representation, just try to call this particular function build vocab. Now inside that pass your data. Then you have to train the model. So you have to give your data, total example. Then total example, you will get total example from the model.corpus count. That means it will count the entire corpus, and it will give you the count, and you have to give the epoch. Okay, epoch, you can take the default actual epoch from the model itself. Now see, my training is completed. Now if I want to see the similar, so similar of Daenerys. So Daenerys is a character inside this particular, let's say, series. So see, she is the character. Now you can see the similar score of the Daenerys with these are the word. Okay, these are the word. But see, again you will get some, let's say, random output, because here we are only using one dialogue. That means one txt file. I'm not using the entire text, entire dialogue, because unless and until my model is not getting the entire dialogue, it would be a little bit difficult for it to match those character. Yes or no, right? So if you're doing it, just try to take all the data and try to perform this job. But here, just to show you, I have taken only one txt file. Now you can see with still word, it is having 0.99 okay percent relationship. Okay, Daenerys. Then and Prince. So Prince is another character. Prince in Games of Thrones. See, with him actually her character is matching. If you watch the series, actually will see that with him her character is matching, okay, mostly. So you can see, then deny, then Dotarki also is a character. See, okay, so that's how we can actually match. Now see, it's not actually properly visible, so what I can do, I can also plot them in a, so what I can do, I can also plot them in a visual graph representation. I'll tell you, but before that, let me show you. If you want to, let's say, see the relationship between two characters, you can use this similarity function inside that give two characters, let's say Arya and Sansa. So if I give Arya and Sansa, so they are having, this is the relationship, okay. Now if you want to get all the vectors, you can execute this code. It will give you all the vectors, okay, all the vectors for the entire text you have given, okay, and the shape of the vector. See, now let me show you the visualization. I will apply the PCA, that means principal component analysis, to reduce the dimension. That means I want to plot in a 3-dimensional space right now. So here I'm initializing PCA component. Now PCA.fit, I'm giving my data, that means vector. So it will give me the 3-dimensional vector right now. That means from 100 dimension, it has reduced to 3-dimensional vector. I think you know what is PCA, principal component analysis in machine learning. We can use it to reduce the dimension size. Now you can see the dimension right now. So this is the dimension 3. And here we are having 3840 example in this particular entire text. Now see, if I want to plot it, I can use plotly library. Now inside that, just pass your data and set the color. See, it will show you the entire representation of the data. See, that's how we are getting a 3D space. See, this is the 3D space. Now see the different word, okay, different word and their similarity. So here you can see they are closely related. These are the cluster. So this word is nothing but, so this red is nothing but, just try to see, it's a take, and this blue is nothing but, it's a put. That means put and take, they are falling in the same cluster because they have the relationship. Okay, if you just find in a grammatical way, you will see that they have the relationship. And apart from that, you will also see some character. Okay, you can also match the character. You will see that they are falling in the same cluster. So you can play with this particular graph. I'll share the notebook. You can play with this particular graph. See, that's how beautifully it has stored the data in the dimensional space. Okay, and that's how your model will identify, okay, the semantic relationship, okay, between two words. That means I showed you now here the semantic information from the word itself. I hope it is clear now. Fine. So yes, so that's how actually we can use this word to vec. And if you're using word to vec, you have to pass this particular data. Sorry, after this data, okay, the vector we are getting, the entire vector, that normalized vector, okay, and this is your vector representation. This vector you have to pass to the model. But again, we won't be using that. We have just learned this word to vec just to understand how my transformer architecture will be working, how it will extract the features, and how it will get the, let's say, semantic information. So in transformer architecture, you use something called attention mechanism, let's say attention model. With the help of attention model, it can actually understand the semantic information in a good way. Okay, this is a little bit advanced concept. Okay, that's the idea. So yes, this is what actually we can perform our data representation, that means text representation. And that's how we can perform the vectorization technique. So why we learned this? Because going forward, whenever we'll be learning about, let's say, large language model and all, before understanding large language model, I just wanted to let you know how data would be prepared for the model. Okay, now I think you got it, how we can prepare our data for the large language model. Okay, if I have any kinds of raw text, how we can convert to the numerical representation and which approach would be better. Because finally we saw that this word to vec approach is better because it is able to extract the semantic information. Okay, semantic information, because it is a deep learning model. Okay, this is the idea. So yes, I hope guys you got it. Now in the next video, we'll be using all the, let's say, topic we have learned so far, let's say text preprocessing and text representation technique. And we'll be doing one small project with the help of machine learning. We'll be doing one text classification project. With that guys, thank you so much for watching this video, and I will see you next time.